It was April 26, 1986. In Ukraine, then a Soviet republic, the Chernobyl nuclear power plant stood.
Reactor number 4 experienced an explosion. A safety test had gone catastrophically wrong. Brave firefighters rushed towards the inferno. They did not fully comprehend the invisible peril.
The explosion unleashed a colossal amount of radiation. This poison was unseen, unheard, yet deadly. It drifted silently across Ukraine, Belarus, and Russia. The wind carried particles of silent termination. The very earth became deeply contaminated.
A new, strange conflict had just begun, a battle against an enemy no one could see. The nearby city of Pripyat faced immediate evacuation. More than 50,000 residents had to leave. They were assured it was only a temporary measure. They left behind their homes, toys, books, and daily lives.
Lines of buses transported them far from their homes. Pripyat transformed into a desolate ghost city. It became a stark monument to human miscalculation. Humans departed from the contaminated lands. The exclusion zone was officially established and sealed. Nature, in its raw form, was left entirely alone. No people walked the streets or tilled the fields. The silence was broken only by wind and animals.
A vast experiment had unintentionally started. What happens when humans vanish from a place? The zone held the unsettling answer. The first few years were a period of intense struggle. Radiation levels remained dangerously high in many areas. Life fought to gain a fragile foothold once more.
The initial shock had devastated local flora and fauna, but the absence of human activity created a void. This void was slowly, cautiously being explored by life. The land was wounded, but not entirely dead. It waited, holding its breath for a new beginning.
Early signs of nature's return were subtle. Small, hardy plants began to push through cracks in concrete. Resilient insects started to reappear in the undergrowth. These were the pioneers of a new, wild world. They were the first whispers of returning life.
Several decades passed since the disaster. The forests within the exclusion zone grew dense and wild. Trees began to reclaim abandoned buildings and structures. Roots cracked concrete, branches pushed through windows.
Nature was slowly erasing the marks of human presence. Green became the dominant color in this forgotten land. The air, though still carrying radiation, felt cleaner. A new, untamed wilderness was steadily taking shape.
Animals returned to this human-emptied landscape. Large mammals like wolves, deer, and wild boar flourished. Species that had been rare in the region reappeared. The European bison, once near extinction, found refuge here.
Przewalski's horses, released into the zone, established a population. The absence of people was a crucial factor. This allowed wildlife to thrive, undisturbed by human activity. The zone became an accidental, enormous nature reserve.
The key to this resurgence was the absence of humans. There was no agriculture to clear the land. There was no hunting to deplete animal populations. There was no industry to pollute the air and water. Nature, left to its own devices, began to mend. Radiation is still a pervasive element in Chernobyl. It lingers silently in the soil, deep within the earth. It is present in the water of rivers and marshes. It is absorbed by the plants that grow abundantly.
This invisible force shapes every aspect of life here. The zone is a constant reminder of the accident. Every living thing exists under its subtle influence. This is the new reality for Chernobyl's inhabitants.
Animals living in the zone cope with this constant exposure. They consume plants that have drawn radiation from the soil. They drink water that carries radioactive isotopes. Their bodies are continuously subjected to low-level radiation.
This is a stress that their ancestors never knew. How they manage this burden is a critical question. Scientists are keen to understand their survival strategies. The long-term consequences are still being studied.
Researchers from around the world come to observe. They study the animals and plants with great care. How do they survive in such an environment?
Whispers of change, mutation and adaptation in the zone. Radiation has the power to alter DNA, the blueprint of life. This process of change is known as mutation.
Mutations can be harmful, leading to illness or death. They can also be neutral, having no noticeable effect. Rarely, a mutation might even offer an advantage.
In Chernobyl, the constant presence of radiation increases mutation rates. This makes the zone a place of intense genetic pressure. Life here is constantly being tested and reshaped.
Dark pigmented or melanized fungi grow near the damaged reactor. These black fungi seem to thrive in high radiation areas. Scientists believe they might be using radiation as an energy source.
This is a remarkable and strange adaptation. It suggests that some organisms can harness this dangerous force. The fungi convert gamma radiation into chemical energy. This is similar to how plants use sunlight for photosynthesis. A truly unexpected turn in the story of life.
Birds living within the Chernobyl exclusion zone show various effects. Some studies indicate higher rates of mutations among them. Barn swallows, for example, have been extensively studied. Some populations show increased albinism or tumor rates. Others have exhibited smaller brain sizes or lower sperm viability.
Evolution on fast forward, nature's accelerated response. Constant environmental stress can act as a powerful evolutionary force. It can significantly speed up the process of evolution. Radiation in Chernobyl is such a strong, persistent stressor. It constantly challenges the organisms living there. Only those best suited to this harsh reality survive. And crucially, they reproduce, passing on their traits. This is the core principle of natural selection.
But here, it seems to be happening at an accelerated pace. Organisms that manage to survive the radiation are key. They carry genes that might offer some form of protection. When they reproduce, their offspring inherit these genes. Over generations, these protective traits can become more common. The population as a whole becomes better adapted. This is evolution in action, observable in real time.
Chernobyl provides a unique, albeit tragic, natural laboratory. We can witness evolutionary changes unfolding rapidly. This is the essence of natural selection at work. It is happening remarkably quickly in the Chernobyl zone. We are not observing changes over vast geological timescales. We are not waiting for millennia to see a difference. Instead, we are seeing shifts within a few generations.
Echoes of Chernobyl, Fukushima, and other abandoned lands. The world witnessed another nuclear accident in Fukushima, Japan. This occurred in March 2011, a quarter century after Chernobyl. A powerful earthquake and tsunami damaged the nuclear plant. It led to meltdowns and the release of radiation. Another exclusion zone was established around Fukushima Daiichi. Thousands of people had to leave their homes behind. The parallels to Chernobyl were immediate and chilling. Humanity faced another stark reminder of nuclear risks.
Nature is also beginning its slow return in Fukushima. Wild boar now roam through the empty towns and fields. Macaque monkeys and other wildlife are being observed. Similar patterns of ecological succession are emerging. Plants are colonizing abandoned spaces, just as in Chernobyl. The absence of human activity allows nature to reclaim territory.
However, the Fukushima disaster is much more recent. The long-term ecological story there is still unfolding. Chernobyl offers a much longer view of post-nuclear recovery. Nearly 4 decades have passed since its catastrophe. This provides invaluable data for understanding long-term effects. It shows how ecosystems can evolve under chronic radiation. Fukushima's journey is still in its earlier stages.
Nature's unyielding resilience, a testament to survival. The story of Chernobyl powerfully demonstrates nature's inherent strength. It showcases its remarkable ability to heal and to reclaim. Even in the face of such a devastating nuclear accident, life has found ways to persist and even to flourish. The zone, once a symbol of death and destruction, has become a symbol of nature's enduring power. This transformation offers a message of cautious hope. It speaks to the deep-seated resilience of the living world.
A crucial lesson from Chernobyl is about human impact. When humans withdraw, ecosystems can show remarkable recovery. This happens even after extreme and widespread damage. The absence of farming, industry, and urban development allows natural processes to take over and restore balance. Of course, the radiation remains a complicating factor, but the primary driver of this resurgence is human absence. This has profound implications for conservation efforts globally.
The Chernobyl exclusion zone is not a pristine paradise. It is important to remember the continued presence of radiation. This radiation undoubtedly has biological effects on its inhabitants. Some organisms suffer and the ecosystem is altered. However, despite these challenges, life is strikingly abundant.
A glimpse of a different future? Chernobyl's lessons for Earth. What profound lessons can Chernobyl teach us today? About the delicate balance of our planet? About the potential trajectory of our shared future? The zone is more than just a site of past disaster. It is a living, evolving story with ongoing chapters. It forces us to confront uncomfortable truths, but also to acknowledge unexpected capacities for renewal. Its lessons resonate far beyond its contaminated borders.
Chernobyl clearly demonstrates that life can adapt. It can adjust even to incredibly harsh, novel conditions. This includes environments heavily saturated with radiation. While the cost of such adaptation can be high, the sheer persistence of life is undeniable. This raises questions about life's limits and potential. Could similar adaptations occur in other extreme settings? Perhaps even on other planets if life faced such challenges?
Could this phenomenon of adaptation be replicated elsewhere? On Earth if other areas became similarly inhospitable? Or perhaps far beyond our world, on distant planets? If extraterrestrial life encountered radiation-heavy environments, could it too evolve mechanisms to cope or even thrive? Chernobyl offers a terrestrial example of such possibilities. It stretches our imagination about where life can exist, and how it might change in response to extreme pressures.
Chernobyl serves as a grave and enduring warning, a reminder of the catastrophic potential of our technologies. But it also offers a strange, unexpected window, a glimpse into a possible, albeit altered form of evolution. It suggests a new, unforeseen path that life might take when faced with unprecedented environmental stressors.